Hi everyone, so we're going to go ahead and go over section 1.6, which goes over complex numbers. So the imaginary unit I is defined as I equals square root -1, where I squared equals -1. So they actually came up with imaginary units in order to describe the square root of a negative number. So complex numbers are sets of the form a plus bi, where a and b are real numbers. So our real part here is a, and then our imaginary part is b. So for example, we have -4 plus 6i, 2i equals 0 plus 2i, and 3 equals 3 plus 0i. So our real part is -4, our imaginary part is 6, and then 0 is also our real part. So in a complex number system, every quadratic equation has solutions because we're able to describe negative roots with our imaginary units. And so it has imaginary solutions. So for adding and subtracting complex numbers, we're going to be grouping the real parts. So this is the real part here after we added, and then we're going to group the I parts, the imaginary parts. So think of I as like a variable in the sense where we want to get all the like terms together. And then subtracting is in the same way. We're going to group the real parts, and then we're going to group the imaginary parts. So for example, we have 5 minus 11i plus 7 plus 4i. We're going to drop the parentheses first, and then we're going to group the real parts, which is 5 plus 7, and the imaginary parts, which is -11i plus 4i. So we get 12 minus 7i. Okay, so here we have multiplying complex numbers. So we have a plus bi times c plus di. And that's going to equal ac plus adi plus bci plus bdi squared. So we're able to group like terms. So we're grouping AC, and then notice how BDI squared, or I squared, equals -1. So we're going to go ahead and do that now. So AC is minus BD. And then we have plus, let me move this I squared out of the way for now. AC minus BD plus, we have AD plus BCI. Okay, so for example, we have 7 minus 3i times -2 minus 5i, and that gets us -14 minus 35i plus 6i plus 15i squared. So we group our terms, and we multiply out the I squared, so we have -14 minus 35i plus 6i minus 15. Move terms around to get like terms together. We have -14 minus 15, which is -29, plus -35 plus 6i, which is -29i. Okay, so dividing complex numbers. We have a plus bi over c plus di. So we're going to go ahead and multiply the numerator and denominator by the complex conjugate of the denominator. So our complex conjugate is set c minus di, multiplied to the denominator and the numerator, and we get ac plus bd plus bc minus adi over c squared plus d squared. So for example, we have 7 plus 4i over 2 minus 5i. Our complex conjugate is 2 plus 5i. So when we multiply by the complex conjugate, we get 14 plus 35i plus 8i, plus 20i squared, and then over 2 squared plus 10i minus 10i minus 25i squared. So we can simplify those I squares. So we get 14 plus 43i minus 20 over 4, and then the 10i's cancel. 4 plus 25. We simplify even further and we get negative 6 plus 43i over 29. And I'm just going to go ahead and break up the fraction. So I have like this, and then I have this. So I have negative 6 over 29 plus 43 over I. So our square roots of negative numbers. So the principal square root of negative b is square root negative b equals I square root b. So we've seen that already, pulling out the I when we have the negative 1 under the square root. So our square roots of negative b are I square root b and negative I square root b. So for example, we have negative 25 plus square root of negative 50 over 15. We're going to go ahead and pull out the negative 1 from under the square root to have I on the outside. And then we have negative 25 plus 5i square root 2 over 15. So we broke up our square root 50 into square root 25, square root 25 times square root 2. So we have 5i square root 2 over 15. And then we could factor out the 5 from the top or split the fraction. So I just went ahead and split the fraction first. So I did negative 25 over 15 plus 5i square root 2 over 15. And then that simplifies to negative 5 over 3 plus I square root 2 over 3. So we're going to go ahead and do an example of a quadratic equation with complex solutions. So go ahead and solve using the quadratic formula. So we have 3x squared minus 2x plus 4 equals 0. So you have the quadratic formula, and then we're going to plug in our values. So we have negative times negative square root 2 plus or minus square root negative 2 squared minus 4 times 3 times 4 over 2 times 3. So we get 2 plus or minus 4 minus 48 over 6. We have 2 plus or minus square root negative 44 over 6. So we're going to go ahead and split square root negative 44, factor out that I, and then square root 44 can be thought of square root 4 times square root 11, and then square root 4 simplifies to 2. So you have 2 plus or minus 2i square root 11 over 6. I'm going to factor out a 2 from the numerator to get 2 times 1 plus or minus I square root 11 over 6 equals 1 plus or minus I square root 11 over 3 equals 1/3 plus or minus I square root 11 over 3. And that's our final answer with our I's. So for Friday, go ahead and do reading on 1.7, and I'll get that video posted up on Friday. Also, I'll be posting up homework on Wednesday, and I'll be sending you guys an email of the update on possibly doing a practice quiz for Friday. And remember, our homework is due Monday, and we'll also be having a quiz Monday. So I'll send out information about that later on. But thank you guys. See you later.